Hello and welcome to OCube, an organization building open source solutions for data intelligence. Today, we're continuing our series of videos explaining how to build a Databricks Lakehouse using infrastructure as code with Laktory, the all-in-one solution for defining both data transformations and Databricks resources. If Terraform, Databricks Asset Bundles, and dbt had a child, it would probably be called Laktory. In this episode, we explore how to configure a data pipeline as incremental and deploy it as a Delta Live Tables. But before we do, if you want to ramp up your data and AI engineering game, make sure to like and subscribe. Before jumping right in, let's have a look at the big picture. In this architecture diagram, we have all the main components typically found in a Databricks Lakehouse, from users management to pipeline jobs. Before watching this third episode on streaming pipelines and Delta Live Tables, make sure to watch previous episodes linked in the description. We start where we left things off after the previous episode. If you remember, we created both a simple Hello World job and a more advanced data transformation job using Laktory's pipeline model. This pipeline loaded metadata and pricing data into bronze tables, transformed them into silver tables, and then joined the two. The outputs were saved as Delta tables and registered as part of the Hive metastore. Today, we'll take it a step further by revisiting this pipeline to demonstrate how it can be deployed as a Delta Live table and updated to support streaming operations. If this is your first time tuning into the series, don't worry, we'll be starting from scratch, using Laktory's Quick Start with the Workflows template. In this stack that defines all the resources to be deployed, we'll remove the Hello World and pipeline jobs, as we covered those in the last episode. The main focus today will be deploying the DLT pipeline. Before diving into the pipeline, we'll first copy a few supporting data files, remove any unnecessary notebooks, and update the resources accordingly. These data files are the same ones we used when building the original data pipeline job, and they can be found in the repository linked in the description below. We're now ready for our first deployment, but before proceeding, we need to initialize the backend using the Laktory init command. Once that's done, we can move forward with deploying to the development workspace. Now, let's take a look at the pipeline. Since we want to deploy it as a Delta Live table, we'll need to set DLT as the orchestrator and configure it according to the desired settings. The core components of any Laktory pipeline are the nodes. Each node represents a data asset, such as a view or table, by reading from a source, applying transformations, and optionally writing to a sink. Supported sources and sinks include disk file paths, data tables, and pipeline nodes. The transformer is a chain of operations where you can mix and match SQL statements with Spark data frame functions, offering a modular and scalable solution when using a DLT orchestrator. Each node is declared as either a Delta Live table or view. In the Quick Start example, we defined both bronze and silver stock prices tables. For more details on their configuration, check out the previous episode of Lakehouse, as code linked in the description below. Since the job we created earlier already writes tables to the Hive metastore, we'll take a different approach with our DLT pipeline this time. We'll write the tables to the Laktory schema in the dev catalog, which we deployed in the first episode. Typically, the catalog and schema can be specified in the sink of each node. But when using DLT, the global configuration takes precedence. Jumping into our pipeline in Databricks Workspace, we see that the expected schema and catalog have been selected. Let's run this Delta Live Tables. What's great about using DLT is that you can visually inspect the generated assets after each run. Here we see that both bronze and silver tables are classified as streaming tables, meaning they are populated incrementally as new data arrive. This is by opposition to batch processing in which the entirety of each table is recomputed at each run. So how do we specify streaming versus batch when using Laktory? It's easy. Simply set as stream to true in the source of your node. This will read the source, and write the sync as Spark structured streaming data frames. Let's take a look at how this setting impacts subsequent runs of your pipeline. No new rows were added or modified in any of the tables. With streaming tables, Databricks Autoloader automatically detects new data files and inserts only the new rows into the downstream tables, making it a highly time and cost-efficient approach. And with Laktory, you bring these streaming capabilities not only to DLT, but also to standard Databricks jobs. Switching between the two is as simple as changing a single configuration parameter. For those of you who haven't watched the previous episode, it's worth noting that one of Laktory's standout features is the ability to develop and debug a pipeline directly from your favorite IDE before deploying it to Databricks. Using the debug PL script provided in the Quick Start, you can load your pipeline definition by reading the stack and execute it with either a local or remote Spark session. Upon execution, the logs will detail exactly how the data flows from one node to the next, showing the source, the transformations applied, and the sync. It even indicates whether the data is read as a stream or not. Even if the output data frame of one of the nodes is a Spark streaming data frame, you can still preview its content similar to using the display command in Databricks. To demonstrate how convenient this debugging capability is, let's add a new column to our silver node and run the script again to validate the changes. Within seconds, we can inspect the result and confirm that our transformation is correct. Doing the same directly in DLT would have taken several minutes. But how is that possible? How can Laktory use this configuration in the context of DLT, where the definition of each table is strictly structured? Let's look at the generic notebook we use to find out. After installing Laktory and other dependencies, the notebook reads the pipeline configuration and instantiates it as a Python object. This is possible because the configuration file has been deployed as part of the pipeline model, and because the pipeline name has been passed as a parameter. Then, we loop across all nodes of the pipeline to create a view or a table for each of them, following DLT required syntax. One key differentiator is that DLT is imported directly from Laktory, giving you access to its powerful debugging features. You can run the notebook on an interactive cluster and preview the results of each table in real time. This is tremendously helpful when building pipelines with DLT. Let's compare the pipeline definition from the previous episode, where we used a job as the orchestrator. Aside from changing the orchestrator itself and selecting a streaming read for the data sources, everything else is almost identical. This highlights just how easy it is to switch between orchestrators while keeping the same data assets and transformations. To complete our exercise, let's copy from this other pipeline the metadata and join tables directly over to our new pipeline. Let's deploy one last time and run our pipeline from the Workspace. A pipeline allows you to combine materialized views and streaming tables, enabling you to leverage the best option for each use case. Once again, everything is controlled through the pipeline configuration. A quick look at the Catalog Explorer shows that all our tables have been successfully written into the dev catalog and are now ready for querying. That wraps up our demo on building the Lakehouse as code with Laktory. Deploying data pipelines that take full advantage of Delta Live Tables has never been easier. With the help of configuration files, you had a solid framework in place, avoiding the uncontrollable proliferation of notebooks that often occurs when using DLT at scale. And the cherry on top, you can run and debug these pipelines directly from your favorite IDE. Hopefully, you found it straightforward to declare and deploy data pipelines. Have you tried deploying DLT as code before? How was your experience? Share your thoughts in the comments below, and we'll see you next time.